In this video, we're going to look at the function f of x is equal to 2x cubed plus 9x squared minus 24x plus 10. In the first part of the video, we're going to determine the subintervals of increase and decrease of the function. In the second part, we're going to find the local extrema of the function, and in the third part, we're going to determine the concavity of the function and then find the point of inflection. Okay, so for part 1, we're going to start off by differentiating the function. What you do is you take the power on the x, you reduce it by 1, and then you multiply the coefficient of that x term by the original power. Okay, so when you've differentiated the whole function, you should end up with f prime is equal to 6x squared plus 18x minus 24. Now, if we let that equal to 0, we can then solve that equation. Here, so first, start off by dividing across by 6, and then this particular equation factorizes to give the answers x equals minus 4 and x equals 1. So what we've done here is we found the x coordinates of the turning points. Now, by looking at the result of the derivative at different x values, we can determine if the function is increasing or decreasing. So if the value of f prime is greater than 0, that means the gradient there is greater than 0, then the function is increasing. And conversely, if the value of f prime is less than 0, the gradient is negative and the graph is decreasing. So what we're going to do, we're going to sub in minus 5 into the derivative, which is to the left of our point at minus 4. So from this we get an answer 36. This is positive, so the function is increasing up to the turning point at x equals minus 4. Subbing in 0, which is of course between the two x coordinates of the turning points, between the x equals minus 4 and x equals 1, we get minus 24, which is showing that it's a decreasing function between the two turning points. Now finally, putting the point x equals 2, which is to the right of our turning point x equals 1 into the derivative, we get 36, a positive result. So the function is increasing to the right of x equals 1. So from what we've done so far, the above calculations, we now know that the subintervals of decrease must be when x is greater than minus 4 but less than 1, and the subintervals of increase must be when x is greater than 1 and when x is less than minus 4. Okay, so now we're going to move on to part 2. So to start off, we're going to differentiate the derivative again to get the second derivative. If we do this, we get f double prime is equal to 12x plus 18. Okay, so now what we need to do here is sub in the x values that we've already found of the turning points. This will determine whether they're a maximum or minimum. If we get a result of less than 0 or negative, we know it's a maximum point. Similarly, if we get a positive value, it is a minimum point. Okay, so subbing in the first x value, x equals minus 4, we get the answer minus 30. So we know that this is a local maximum. After subbing in the x value, x equals minus 1, we get 30, meaning that this is a local minimum. Now what we need to do is to find the y values of the x coordinates of the turning point. All we've got to do for that is just sub in the two x values into the original equation. So sub in x equals minus 4, as you can see, we get 122, which means the coordinates of the local maximum are minus 4, 122. Similarly, if we sub in x equals 1 into the original function, we get minus 3, which gives the coordinates of the local minimum as 1, minus 3. Okay, so what we're going to do now is we're going to move on to the third and final part of this question. So we're going to try and find the concavity. So what we're going to do is set the second derivative equal to 0 and then solve this. So if we set 12x plus 18 equals 0, we find that x is equal to minus 3 over 2. To the left of this, we know there is a local max at x equals minus 4, which tells us the function is concave down to the left of x equals minus 3 over 2. Similarly, to the right there is a local minimum at x equals 1. So we know that to the right of x equals minus 3 over 2, the function is concave up. Okay, so for For the final part of this question, we need to find the coordinates of the point of inflection. All we've got to do here is sub in the point x equals minus 3 over 2 back into the original function, as we did earlier. And as you can see, we get 73. So the coordinates are minus 3 over 2, 73. Thanks for watching this video. I hope it helps, and see you soon.